All right. So finishing up inverse functions today. And we're going to look basically at um, graphs, but then we're going to incorporate the things that we did yesterday. So a few bits of information first. So properties of inverse functions. For every point with coordinates x, y on the graph of a function, there is a point yx on the graph of its inverse, and vice versa. So when we were working with the functions, to find the inverse, we switched the x and the y. Same idea with graphing. The domain of the function is the same as the range of its inverse, and the range of a function is the same as the domain of its inverse. So again, the x's and the y's switch. Because of that, the third item happens, and that is the graph of a function and its inverse are reflections across the line y equals x. We'll take a look at that when we do some graphing. So in order for a graph to represent a function, you might remember it has to pass the vertical line test. In other words, a vertical line can pass through at most just one point, and then you have a function. With inverses, we have something called the horizontal line test. Same idea, but the horizontal line test tells us if a function is one-to-one. So if a horizontal line passes through just one point on a graph, uh, that function is one-to-one, and that means it will have an inverse. If it's not one-to-one, and the quick example that comes to mind is like a parabola, what we can do is just look at a certain part of that function to make it one-to-one, and then it will have an inverse. And we'll see one of those here in just a second. You'll also see a few on your homework. So your homework is going to look like this. And it's actually going to say, like, sketch the graph of f in blue. Um, I would just say, like, if you have different colors, that's fine. Otherwise, a pen and a pencil work great. Find its inverse. Verify that the inverse is correct. And remember, we can do that by taking the composition of the function and its inverse. Sketch the graph of the inverse. State the domain and the range of the function and its inverse. And so there are some kind of easy ways to note those things, and I'll go through those as we go through the problem. So here we have a parabola, but we're only concerned with points where x is less than or equal to 0. So one way to graph is just by picking some values. If I plug in 0, I get -4. And I think you're going to be asked to label the points in your homework. I should double check. Label at least 3 points. Okay. And so you can just pick 3, like 0, -1, and -2. And obviously there are more points that you could pick, but this gives us a little bit of an idea. Then we're going to find its inverse. I'm not going to worry about the x is less than or equal to 0 at this point. Maybe you'll see why here in a minute. So switch the x and the y and solve for y. I'm actually going to change that a little bit. And when I take the square root, normally I'll put a plus and a minus here. Now, in this case, for our function, our x values were negative. So for our inverse, the y values are going to be negative. So I want the negative square root. Kind of a interesting little twist there. So my inverse function is the negative root of x plus 4. Excuse me. Verify that the inverse is correct. So now I'm going to take f composed with f inverse. So I take this and plug it in for x in my original. When I square, the negative goes away because a negative times a negative is positive, and the square root goes away. So that verifies my inverse is correct, because if I take the composition of the function and the inverse, I do get x. That's nice. Graph. So my suggestion when you graph is just take the points that you've labeled and switch the x and the y coordinates. So instead of 0, -4, we would have -4, 0, -3, -1, 0, -2, and so on. And I think it will, oh, it doesn't, never mind. So it's not going to ask you to label the points. I still don't like that graph. Perfectionist at work. There we go. All right. Now for domain and range. So the domain of f actually we're given right here. X is going to be less than or equal to 0. So domain of f. All x's such that x is less than or equal to 0. range of f. Range talks about y values. And if I look at my y values, I start at -4 and I go up forever. So y is going to be greater than or equal to -4. For the inverse, just switch the x's and the y's. So x is going to be greater than or equal to -4. And y is going to be less than or equal to 0. So the domain becomes the range and the range becomes the domain. And you can see here, I think, that the red graph starts at a -4 for x and goes all the way to the right. It starts at 0 for y and then goes down. So I think that works to verify our domain and range. All right, one more. So same thing, sketch the graph, find its inverse, verify that the inverse is correct. 3x plus 2 . So there's our line, y-intercept of 2, slope of 3. Find the inverse. So if y equals 3x plus 2, switch my x and my y. Oh, I've got one other thing to do with that graph. I forgot, but I'll get to that in a minute. Solve for y. I started thinking before I started writing before I started thinking. That should be -2. My mistake. Sorry about that. So x minus 2 over 3 is y. That's our inverse. I forgot to label my 3 points here. Oops. Zero, 2, 1, 5, 2, 8. All right, verify that that's actually the inverse. So 3x minus 2 over 3 plus 2. Again, taking my inverse, plugging it into my function wherever x is. The 3's cancel. And the -2 and the +2 cancel. Leaves me with x. So that verifies my function and its inverse. Again, they call that the fundamental property of inverses. So that's just plugging or taking the composition of the function and its inverse. Graphing. So if I graph those same 3 points, just switching and I'll label them. You don't have to do this in the homework, but all I'm doing is I'm switching the X and Y coordinates. And those lines extend obviously forever. I hope that's obvious anyway. So the domain and the range actually are pretty easy. Domain of F is all real numbers, or you can write it as -infinity to infinity. Range of F, also all real numbers. So when you do the domain of the inverse, that's the same as the range of the function, so it's all real numbers. And the range of the inverse. One of the things that we said was that a function and its inverse are a reflection over the line y equals x. So I just want to draw that in real quick to show it. So I'm just going to make a dashed line through my graph. If I can get this to stay where I want it to stay. So basically we take the blue line and flip it over that dotted line to get the inverse. All right. So that'll be what you're doing for your homework. I figured there was enough in there that 12 problems was more than enough to keep you busy.
All right, sounds good.
All right. Have a great rest of your day.
Thanks, you too.
Thank you.